talking. I said, well, I'll wait for you. How's everything going?
We finished up the last senior design group through there. And we got the
Yep. I think it's going to be a lot of fun.
Please show us your working prototype. Tail down and explain how it works.
Unfortunately, my teammate a laptop to control it had no basically, we could have a computer here, it's just controlling another microcontroller here. The method we were using was method 1 right here. We did 2 methods where microcontroller 1 and 1 with the radio frequency transmitter, which would be this one right here, would send a synchronizing ping from this transmitter to be picked up by this receiver over here, which would then be recognized by the microcontroller, which would transmit a signal to the ultrasound transmitter, which would send an ultrasonic ping of 40 kilohertz to the receiver here, which would then pick it up, demodulate it, and send it to this microcontroller here to be received. And that's basically the layout which you see here. Here's a graphical representation. Is that at time 1, the ping is sent, and then microcontroller 2 picks it up at time 2, and from which it signals the ultrasound transmitter to send the ultrasound. That's T3 after some delay. That delay is usually constant. It can be measured. And then it takes the time of flight for that ping to travel to the other microcontroller to the receiver. That's T4 is the time that it takes for the microcontroller to recognize it. And then it takes this distance minus this distance, and that'll give the total time it took. And then it subtracts from that the time it took for the ultrasound to be sent and the average synchronization time for the average time it takes for the ping, the original ping to reach the microcontroller. And that'll give us the time of flight and how long the ultrasonic ping has been sent. And then we multiply that by the speed of sound to give us the distance. Well, there are various methods of synchronizing microcontrollers like this. I like to make it much more expensive. Our goal for this was for the reputation masters for his project, which would eventually have been turned into an ultrasonic positioning system, which he was aiming for sub-millimeter accuracy to track an object in 3D units. Very accurate precision. So that's part of the project where they see it. As far as there's things like that, there's different systems that can do similar things. You take like a second mic and make it projects like that.
So what does it
honestly, that's a pretty good question. This it's basically our way of synchronizing. There's so many different ones out there. And this was being specifically made for information, so we don't know if there's exactly basically for UTDesign, we're still testing various chips and computers, transceivers and receivers. And so from what we did from that was we built an ultrasound system to receive the voices and recognize them. We got the microcontroller up and running a program to recognize the things being sent to calculate the distance between the two. So basically we looked at what we did So basically, we would change it to recognize this. We would change our hardware to be more sensitive to the